Welcome. I'm glad you all are still with us. I'm super excited to be a part of this conference, even though we are not in person with each other. And so normally I would ask you all to raise your hand and answer a question. But instead, I want to start by asking you all to just think about your web app for a moment, the one that you work on day to day at your job. Kind of visualize the UI, think about how your code is structured, and in particular, how it requests data. If you have all that in your mind, if I had to guess, your web app probably is built with a bunch of components that make up its UI, because that's the modern architecture for web applications these days. It probably looks a little nicer than this, but I would bet that those components also populate their data by making some request to some backend data source, some API. That the web application that I work on at Netflix does this exact same thing, but it does something a little bit interesting that a lot of other apps don't do. And that most of the components on the page actually have to make separate data requests for different data sources because we aggregate data from a whole lot of different places. So in other words, we make a lot of different data requests. Now, I love working on web apps because I get to work with JavaScript, which I think is a really fun and interesting language. But it's also single-threaded, which means that when we have to do things like this, making lots of data requests, performing lots of data operations, we frequently get tons of loading spinners just kind of waiting and waiting. And then eventually, our page might freeze and maybe it crashes completely. And then our users are going to get frustrated and angry and maybe just completely rage quit from our application. Now, I wish I could say that this is an uncommon problem, but there are memes about it all over the place. We hear about slow websites all the time, especially now that everyone is on the internet more than they usually are. And we even have entire conferences about the subject like we are at currently. And honestly, this is all understandable, right? Web performance is a really complicated topic, as we've been seeing and hearing about. And I'm by no means an expert on every facet of it. But there's one aspect that I find really interesting, and that is, how do we answer this question of how do we prevent numerous large and or slow data operations from impacting our users' experience? There are lots of approaches to answering this question, and it's a really important one because modern web apps are all loading data from various places. And it's important for our users to be able to access that data. But one solution that I found particularly intriguing and fun to work with is web workers. Web workers allow us to have multiple JavaScript threads and to handle many requests, process lots of data, and even deal with slow servers without blocking our browser's main thread, leaving our users with a better and smoother experience. But they're not exactly the easiest construct to work with because their API doesn't really conform to the patterns that we see in a lot of modern web frameworks. So in short, I find that they help, but they can also complicate things if you're not careful. And so today, I want to talk a little bit about how we can get out of our users' way and have less janky experiences on the web by using web workers. I'm going to show you some patterns to make working with them easier, and we're going to go from the pretty much the very basics of web workers, what they are and what their API is like, all the way to some advanced patterns and some things that are just now starting to be possible on the web platform. So buckle in because there's going to be quite a bit of code. All the slides will be available online after the talk, so don't worry about that. And let's dive in. Now, as was mentioned before, my name is Trent Willis. You can find me online at Trent M. Willis, and I'm a senior UI engineer at Netflix, where I work on internal tools that deal with tremendous amounts of data. And this is a screenshot of my character in Animal Crossing. I figured I had to throw that in for this conference. And this little guy you'll see pop up every now and then throughout the talk is called Spidey, and he will be our quote-unquote web worker to highlight some important bits of information, things that I think you should probably take away from this talk. So let's dive in. If we're going to start from the very basics, what exactly is a web worker? Because some of us might not be very familiar with it. Well, in the W3C spec, it's defined as a construct that allows web application authors to spawn background workers or processes running scripts in parallel to the main page. In other words, it lets you have more than one JavaScript process running at once. And this is a really powerful concept. But interestingly, the API surface area for it is actually kind of small. There's not a whole lot to it that you need to know. You start by just creating a web worker by calling new worker. And you give it a file path of a script to load. And this creates what is known as a dedicated web worker, which stands in contrast to a shared worker. The primary difference between the two being that a shared worker can be used by multiple pages at the same time, while a dedicated worker can only be used by one. For this talk, we're only going to talk about dedicated workers because they're both a bit simpler and much more commonly used, though the concepts we'll be talking about could be applied to both. So anytime I refer to a worker, I mean a dedicated one and not a shared one. Now, by default, when you create a worker, it's going to load the script at the specified file path and start it in a new JavaScript thread. In essence, it's quite a bit like using a script tag, except for instead of loading the code into the main thread, it loads it into a new thread. And just creating a worker like this would allow you to execute some JavaScript. But that's not particularly useful for most web applications, which run in the main thread and need to be able to communicate with that secondary process. So the W3C spec actually allows for web workers to communicate with the main thread with message passing as the coordination mechanism. Messages are essentially just JavaScript events, which you are likely already familiar with. So let's walk through real quick what this looks like. How do you communicate with a worker thread? If you have your worker in your main thread, all you have to do is call post message on it. And you can pass in some data, and that data will be cloned and then passed into the worker thread. And you can pass almost any type of JavaScript object with a few exceptions. Most notably, you cannot send functions or objects that contain functions. These rules are all defined by an algorithm called the structured clone algorithm, which you can look up if you're interested in. But in short, what happens is the data that you pass in is actually a clone, so it's not the same reference value. So if it's an object, you actually have a separate copy of it when you get it in the worker. So in the worker thread, you then have access to a global object called self, which you can think of as the window object for your worker's context. And on that object, you can attach event listeners to listen for those messages that are getting sent from the main thread. And you can access the data that was sent in under the data property of that event. And at this point, you can do whatever you want with the data. You could do super slow and complex data processing, and it's not going to impact the main thread at all because you're totally separated at this point. And then once you're done with that data, doing whatever you need to do, you can send it back to the main thread by calling post message on self. And this is pretty much exactly identical to the post message function that you call on the main thread, except it goes in the opposite direction. And since that's the same, you can probably guess how you receive the message on the main thread. And that's through using the add event listener on your worker. Sorry. And so once you receive your data back on the main thread, that's pretty much the majority of what you need to know for your APIs. Sorry, one second. My screen's a little wonky here. Okay. So like I mentioned, there's not a whole lot that you're going to commonly interact with. The only other really interesting point worth mentioning for this talk is the terminate method, which as it describes is going to terminate the worker thread that's associated with your web worker instance. So if you're done using a web worker, you should terminate it to free up the computing resources that were allocated to it. Kind of like Taylor mentioned yesterday, you want to be good stewards of how you impact a user's computing resources, right? So to summarize all of that, because it can be a bit confusing in code, we can look at a graph of what the web worker lifecycle typically looks like. If you have your main thread, you're going to create a worker at some point, and eventually you call post message in the main thread. That'll send some data into your worker, where you can then receive it using an event listener, process that data, and then eventually you can post a message back to the main thread. And at that point, you can either repeat the process or eventually terminate your worker. So if the web worker API is relatively simple, we just covered pretty much the bulk of it in about 6 minutes, how does this complicate things? Well, there are a few main problems. The first is that it's really hard to know when a worker's task is complete, because the way you initiate a task is just by sending a message to it. But the way that you receive updates about that is through a message event that comes back somewhere else in your code. And so that gap makes it really hard to answer the question of, when am I done? When is this task done? And so that gap between initiation and completion of events can be really complicated to maintain over time, especially if you start using multiple different workers and have multiple different tasks that are going on concurrently. So furthermore, this gets even worse if you try to introduce multiple different workers into the equation. Say you have one worker that's doing one task and another worker doing another task. And then you have a third worker that's actually waiting for the first two. How can you manage all of these different events going everywhere without things getting quickly turning into a ball of spaghetti code? And so this is a problem that I've seen a lot of apps run into when they start using web workers. Is it starts out really great, but then eventually down the road, it becomes really hard to maintain and debug. And this is only exacerbated by the fact that web workers are also a little difficult to test. They don't usually follow the same procedures as most commonly written forms of JavaScript, because you're literally context switching between different threads of execution. And so how do you unit test a message, right? And if you can figure out how to unit test those properly, how can you actually stub out or mock external calls within the worker thread? Because oftentimes what you're doing in web workers is making calls to the network. And as a final issue, and this won't apply to all cases, but web workers don't really allow for dynamic definition of workers. So if you don't have your worker code already split out into a separate file when you deploy, or if you're bundling your assets a particular way that makes it difficult to split out separate files, then it's going to be really difficult to actually use web workers. It would be great if instead you could just pass in a function to the worker constructor. But unfortunately, this is not actually possible. So there you have it. Those are what I see as the four main problems that I've seen a lot of developers run into when they try to use web workers, which I actually think is hindering their adoption because they're really powerful, just a little clunky to work with. But all these problems have solutions, and we can solve them by building on top of other tools that the web platform already gives us. And so we're going to take some time to look at solutions to each of those problems that I just presented. So first up, if it's hard to know when a worker's task is complete, well, what we need to do is make it so that we can kind of represent that initiation and completion of the event in a single line. And so if we think about what features the web platform offers, there's already a concept or a construct for this, and that is promises. And so our strategy here should be to turn the messages of a worker into a promise. And in essence, replace one platform interface with another one. This way, we no longer have to track the invocation and resolution of our worker functions in separate areas of our code, and instead we can kind of wrap it up into a single helper function that looks like this. So this method here would take in a worker and a message, pass that message to the worker, and set up a custom message handler that resolves a promise that we return back to the user. Then when you want to use it, you can have a single line where you have your message passed to your worker, and then you handle the response using .then from the promise. And this becomes really nice and readable when you start using the async and await syntax. Now, this is a relatively naive solution, right? It doesn't take into account if the worker gets invoked multiple times or if the message being received is for completion of the expected task, but it does show us an example of how to think about building an abstraction to handle these use cases. For a more robust version of this concept that has already been implemented as a library that you can use in your app, I would encourage you to check out Promise Worker by Nolan Lawson. So moving on, our second problem here is how do we manage and coordinate multiple workers at the same time? Well, the first part of this is to actually just use the last pattern we talked about, which is to change our messages into promises. Simply co-locating that invocation and resolution logic into a single construct makes it really easy to avoid a lot of spaghetti code. The second part of the solution is then to actually just build on that idea and think about each of the different tasks that we'd be invoking in our worker as different methods that we can call on the main thread. And what I mean by this is provide an abstraction that makes your workers look more or less like any other JavaScript class or function that you're interacting with. Right, this would enable you to use similar practices and patterns that you're already employing to manage the rest of your code base. So as a quick example, if we had 3 workers where 2 of them were fetching data and processing it from different backend data sources, we could expose fetch methods on them. And then we could have a third method that's in a worker that processes the combined result of that data. Now, without any abstractions, we would have to have several different post messages being invoked and several different message handlers checking the messages that are responding. But by abstracting all of that away into some nice helper functions, it becomes a lot easier to manage this code over time. And in fact, you wouldn't even really know that this code was running inside web workers if it wasn't for the fact of the names that we had given to the objects. So in my opinion, this seems like such a huge improvement over the default messaging interface that honestly, when I first was introduced to this, I didn't think it would be really possible to implement this in an easy way, a generic fashion. But there are actually several projects that do this. One, which we've already heard briefly about, is called Comlink, which will take an existing web worker you have and wrap it in a proxy on the main thread so that you can send promise-based messages instead of raw messages. And so this is really great if you have existing web worker code that you want to have a nice main thread API. The second project that you could think about is called Workerize, which was made by Jason Miller, or developed it as he's known online, the creator of Preact, which will actually take a JavaScript ES module and transform it into a worker at runtime and give you a promise-based API back to invoke its methods by on the main thread, but it will actually run the code inside a web worker. And so that is a really awesome project. And if you're thinking about using workers and use ES modules, I would encourage you to check it out. And finally, there's import from worker, which is a relatively newly released package, which imports a JS module at runtime using the dynamic import syntax, but then runs the code in a web worker. And so this is really cool if you're starting to use dynamic import and are on a browser that supports running actual modules inside web workers. So on to our third problem, which is then how could we dynamically define workers? Right? This actually has a relatively widely known solution in terms of things that relate to web workers. And that is that you can create a worker using the blob URL of a JavaScript function. Now, if you're like me, or most other developers, I know you probably don't run into blobs very often in your web dev work. So what exactly does this mean? Well, a blob is simply an object that represents some file-like data. And that data could be a simple string. And so if your string happens to contain some JavaScript code, what you essentially have is a file-like object that contains JavaScript code. Your web app can then create a temporary URL from that blob and then load it into a web worker. And voila, you've dynamically defined a web worker. Now, rather than trying to implement this whole convert function to blob dance yourself, you should use another library developed by Jason called Greenlit. It's actually just a subset of the functionality that Workerize mentioned earlier provides. And you give it a function, and it turns it into a promise-based method that runs inside a web worker. And so at this point, we've covered solutions to 3 of our 4 big issues with web workers in several awesome packages. But before we get into talking about testing, I want to take a minute to kind of summarize them because they're all kind of similar, but they all serve different use cases. So first up, Promise Worker will help you turn messages that are being sent to your worker into promises. Greenlit will let you turn a function into a web worker. Workerize will then turn a full ECMAScript module into a web worker. Comlink lets you take a web worker and turn it into a main thread class that serves as a proxy to invoke methods by. And then finally, import from worker will let you load up an ES module using dynamic import syntax as a web worker. Now, these are all really cool ideas, but I haven't seen them used in many apps, so I want to take a second to actually talk about the app that I work on at Netflix, where we do use some of these ideas. And that's called Lumen. So Lumen is a self-service dashboarding application where we let users create custom dashboards using some JSON configuration that then can talk to basically any backend data source that they want it to. And then we have some small JavaScript functions to transform data. So you can find out more about this on the Netflix tech blog at bit.ly/Netflix-Lumen. But the important feature to know is that for a given dashboard, you might have umpteen different data requests being made. So for instance, on this dashboard, we're actually sending 4 different Elasticsearch queries, one for each chart. And we process all those requests and all the data transformations inside web workers. And we communicate with them via promises. So in short, the majority of data operations that we use in Lumen are done in web workers. And this allows us to keep that main thread free for user interactions, such as scrolling or being able to interact with individual charts while the rest of the data for the dashboard loads. So this is a real world and actually critical application for Netflix's operations. And it uses most of the techniques that I've talked about so far. One other example, which I just learned about yesterday during Aaron Turner's talk, is Vaporboy. And I thought this was so cool that I had to include it in this talk, which is a WASM-based Game Boy emulator that runs within a web worker to keep the main thread free for user interactions. So I looked into the code briefly, and he uses some of the patterns discussed here, such as providing promise-based messages and a custom abstraction around web workers. So I'd encourage you to check it out. I think it's a really awesome project. And it segues nicely into the next topic, which is going to be talking about some more complicated patterns you can do with web workers beyond kind of this basic just data processing that I've been talking about so far. And that is, you can do worker-to-worker communication. So web workers don't just have to communicate with the main thread, they can actually communicate with each other and allow you to actually be able to weave a web of web workers if you wanted to. Now, why might you want to do this? Well, it's because each worker is single-threaded just like the main thread. So if you have lots of separate tasks that you need to perform, or just one big task that could potentially be subdivided, it would be really great to kind of separate all that out. Now, there are two ways that you can do this. The first is to simply create another web worker inside your first web worker. And then you can just reuse a lot of the strategies we've already talked about. But if you don't want your worker to communicate or manage other web workers, which seems reasonable, you can follow the second strategy, which is to actually communicate between them using message channels. So the message channel API is an object that basically defines two message ports, which are essentially just message senders and receivers that allow you to communicate between different execution contexts. Except for they're not bound to a specific execution context, so you can move them around. So how does this work? Well, if you had two web workers, you can create them in your main thread or inside a web worker, up to you, and you want them to talk to each other, then what you can do is you can create a message channel object and take the ports from it and send them into the two worker contexts. But you might remember that earlier I said that you can't actually send functions using post message. So how does this work? Well, we can transfer them in their post message method by sending a second parameter, and that allows you to define an array of transferable objects. And transferable objects are essentially objects that can be transferred between different execution contexts. So what this means is if you had two threads, your main thread and your web worker, and you're trying to send a normal object across that had a function on it, you would run into issues. It would cause problems. You couldn't do it. But if you have a transferable object and you try to send it across, what actually happens is you're left with essentially a ghost reference in the main thread, where if you tried to access it, it would error out. And instead, that whole reference gets moved into the web worker rather than creating a clone of it. And thus, you can still continue to use those functions. So in our worker, when we receive a message, we can check to see if it has ports or some other transferable object attached to it. And if so, we can then start to use them. And at this point, we know that we have a port and it's sending data somewhere, but we don't know if that context is the main thread. It could be another web worker, or it could even be another service worker. So unfortunately, this whole song and dance is kind of convoluted to set up, but it gives us a lot of power when thinking about how we architect our applications and getting things off the main thread. So if we think back to our example earlier where we had 3 different workers processing data in different stages, you could actually move all of this so it never touches the main thread. You could have the backend workers actually just pipe data directly into the processing worker. And so you could set up some really powerful and complex architectures without ever having to touch your browser's main thread, leaving it completely free for our users to continue to interact with it and do what they set out to do. But there's more that we can do. For instance, if you wanted to have some really complex canvas-based graphics like WebGL rendered stuff, you can also do that off the main thread nowadays as well, using the Offscreen Canvas API. This gives you access to a canvas context that's actually rendered in the browser, but all the work gets done in a web worker thread. You use it more or less like a normal canvas context, but it's out of the way of user interactions again. And so this is really awesome for displaying complex graphs or WebGL-based images where the computations for each frame might be really heavy, but you want the user to still be able to interact with your UI. But canvas rendering isn't all we can do. We can actually go even further and start thinking about moving DOM operations into web workers. And so the folks over at the AMP project at Google have been working on a library called Worker DOM, which is highly experimental last I checked, but is a really cool concept because it would essentially allow you to offload all of your app's rendering and DOM operations into a separate thread, which would reduce a lot of jank for most modern web apps. So imagine a not so distant future where you're able to fetch your data, process it, generate some lovely custom graphics on a canvas, and then render the DOM and UI for your entire app, all without ever having to touch the browser's main thread, meaning that your users can continue to scroll around, click on things, and read content without having to worry about any jank. I think that's a really exciting prospect. So as an example of kind of putting all these concepts into play, I put together a small demo of Conway's Game of Life. And a real quick overview for those of you not familiar with Conway's Game of Life, it's a 0-player game where you start essentially with a set of inputs and then let them evolve over time according to a set of rules. And so what you get is a small little world that you can kind of watch if it's rendered. So in this first clip, everything is being done on the main thread, and it's super slow and janky, and if you try to click the button, it doesn't respond right, and the background animation is even lagging. But if we moved all that work into a web worker using some of the stuff that I've talked about and use Offscreen Canvas, all of a sudden, everything becomes nice and smooth. The image is still updating kind of slow because the work is intensive, but the user can still click and the animations still behave nicely. So the point of all this so far has basically been that you can do a lot with web workers, much more than people know, and more things are continuing to come. But we're still left with one problem, and that is, how do we test them? A lot of people run into issues when they start trying to test their web worker code. And there are two basic approaches that I've seen people take, one of which I don't think is really that great, and one which I think is pretty solid. The one that's not so great is to run the testing framework in your worker code in the same thread. Now, at first, this seems appealing because it's similar to how you test most other JavaScript code, right? You can load up everything into the main thread, like your test framework, your worker code, and then your tests. Or if you want to get really weird, you could try to load up your testing framework into your web worker. But the problem is that most test frameworks don't run in web workers, and most workers can't run in the main thread if they're using things like self or import scripts or one of the other web worker specific APIs. But even if those weren't problems, you're left with the issue that this isn't actually how web workers get used in reality. So you frequently are writing tests that don't reflect reality or have to modify your code to just support your testing environment. Instead, I think the better approach for folks to take is to essentially realize that your web worker is a black box function. You send in some inputs and you get back some outputs, and what happens in between isn't really that important. And so if you combine this idea with the pattern of turning all of our worker interactions into promises, it becomes a whole lot easier to just write normal function unit tests, right? You can just instantiate your worker, send in a message, and then wait for the promise to resolve and then assert on the results. That said, this doesn't cover all of our use cases because there are some cases, like I mentioned earlier, where maybe you want to go to the network or do some external task. And so how can you stub that out in a web worker when it's running in a different thread? Using sign-on or Jest's mocking capabilities isn't sufficient. Well, in short, it's not straightforward. So I made a package to help you with this exact issue. It's called Worker Box, and it allows you to inject some code into the preamble of your worker so that you can stub out or mock things or any other modifications that you need to make in order to properly unit test your code. Now, I know that this is named very similarly to the service worker package, Workbox, but I named it before I was aware of that. So unfortunately, I can't do much about it right now. Or I could, but I don't want to. If you want some more detailed examples, you can check out the test I wrote for the Game of Life demo I showed earlier. Now, there's a lot more I could say about testing workers, but I don't have time for it. And that really is the bulk of it. Apply the patterns we've talked about, treat them as unit tests, and then leverage Worker Box if you need some stubbing or mocking in a different thread. So that brings us to the end of the talk, right? Web workers are really powerful. I hope I've convinced you of that. They give us the ability to deliver much better user experiences by getting work off of the main thread and out of the way of our users' interactions. But you should probably avoid using them directly. Their API makes it hard to know when a task is done. It makes it difficult to manage multiple workers and grow your code base over time. And honestly, they're hard to maintain over time as well. So instead, stand on the shoulders of giants. Take advantage of the libraries that make working with web workers easier. Use the patterns and abstractions we talked about today, and make web workers a standard part of your application where it makes sense. Web workers, they're only going to continue getting better and better as patterns begin to evolve. And as Melanie emphasized yesterday, we don't know everything and we're all improving continually. So let's improve web workers together. So there's no better time, in my opinion, to start using them than right now and be part of that journey of making experiences better for our users. So thank you all for listening. Here are some additional resources. I'll be posting these slides online shortly, hanging out in Slack after this talk, and I'll probably be jumping in the Trent Google Hangout room at the next break. So if you want to talk, come find me.